Let's talk about dependency container and dependency injection in Medusa. So generally speaking, dependency injection is a design pattern that involves passing the required dependencies to a class, as you can see on the screen. For implementing this, Medusa uses the dependency container, and you can imagine the dependency container as a big box which contains all of the dependencies that you can get at any time that you want. Let's look at the example of onboarding service. Here in the constructor, we have the onboarding repository, a dependency that onboarding service needs. I have prepared a diagram to explain it. So on the left side, we have the Medusa dependency container, which contains onboarding repository, manager, and other stuff. And on the right, we have onboarding service. And so every time Medusa is starting, the container registers a new onboarding service and as an argument passes the container. Let's create an endpoint and test the dependency container over there. So instead of creating an object class onboarding service and passing the required arguments to it, we can use the dependency container. In API routes, you can do it by using the request_scope.resolve function. We can also pass the generic to resolve function to get the typings right. And now let's go to the onboarding service and create some custom method. We will return some string, it doesn't really matter. Now let's go back to the route handler and execute this method and actually return to the client. Now, if we would start the backend and go to the Postman and hit that endpoint, we would get the text that we defined in a method. Now, let's go furthermore and create new service. In this example, I will use the test service. And let's create some method and then execute this method in onboarding service. Also, some of us will wonder, why do we use the super keyword in a constructor of a test service? So the test service actually inherits the transaction-based service class, which is used for handling transactions in a database. So we should pass the required arguments to the transaction-based service via the super keyword. Let's go on by creating a new custom method. It will be the same, except I will change the return string. Also, I will remove unnecessary imports. Let's go back to the onboarding service. I will also add the test service to inject the dependencies type to have the typings right. And here in the constructor, we can access the test service and assign it to the onboarding service property. Just by this. And now, if you would execute the this.testService custom method, it will return the string that we define in a test service. Cool. And now, if we would start the backend and go again to the Postman, we would see the new string. I also want to show you how you can access the dependency container in the subscribers of Medusa. Let's define a new test handler. I'll be using the example from the README. And here you can access the container by container.resolve. And let's just pass the test service. And now we can use the test service in a ordered place handler body. Also, I want to highlight that we also have registry resources that we can access by default, like the config module, which is defined in Medusa config.js file. We also can access the entity manager via the manager property. For the most cases, manager is used for handling the transactions in the database. Medusa also has a login system that we can access with the logger property. And with the logger, we can log different messages on different level, like error, failure, success, debug, info, and others. Let's test it. I will also pass the logger as a generic. And now, if I send a request to the store custom endpoint, I would get this message in the console. Also, I want to note, if you want to see every single registered resources in Medusa container, you can go to the dependency injection reference in the Medusa documentation. Now, I want to emphasize how Medusa registers resources under proper names. Let's look at the diagram that I have prepared. And so, as you can see here, the registration of resources in the dependency container is file-based. And so, if something is under the name test in the repositories, it will be the test repository. The same goes for the services. If something is under the services test directory, it would be the test service using camel case. So let's see how it works under the hood. I went to Medusa repository. Under the loaders directory in the services file, and here we have a logic how Medusa registers resources under the services directory. So here Medusa just getting all the files from the services directory, iterates every single one of them, format the name using the file name, and then throw it in the container. We can also see the same logic behind the models registration. I also want to emphasize how dependency container is crucial, as Medusa comes with the essential commerce endpoints like cards, customers, products, and others, and also how we can easily override the logic behind the roads. Imagine you want to change the listing logic behind the list products endpoint, and you find out that the endpoint uses the product service and the list and count method. And so we can create our own product service and override the list and count methods and add our own logic. We would see an example of it in the services chapter, but right now I just want to make it all clear how it works under the hood.